Okay, welcome to the School of Computing in Dublin City University. My name is Renat Verbruggen and I'm the director of the M.Sc in Computing program. And the webinar today is set up in order to explain to you the structure of the M.Sc and the modules that are within the different majors, but also to give you some background about the school within which the M.Sc is held. Okay, so as you can see from the agenda there's an overview of what the School of Computing is, a tiny bit about the undergraduate programs, just in case, and then we'll talk specifically about the postgraduate programs. We have them at both thought level and research level, i.e. M.Sc and PhDs by research. And then just to, again, give you a good idea of the research expertise that is associated with the school, I'll give an indication of the different research centres that are located beside and within the school. My name, of course, is Renat Verbruggen, as you can see there. So what's the School of Computing about? Well, we've been a school of computing. In fact, we started off as a school of computer applications since the university opened back in the 80s. We're quite a large school from an Irish point of view, with top of the range computing facilities, obviously, but we have a strong academic team that's focused on teaching and research and also in outgoing projects in terms of society. Our degree programs are highly recognized among employers, with huge amounts, percentages of people being employed every year from them. And our undergraduate degrees have a fantastic reputation. So despite the economic pressures and other aspects of society, our graduates are still highly sought after in industry, both in Ireland and abroad. We kind of look at our excellence in teaching as being linked to our excellence in research. So the findings of our research feed into our teaching, and the feedback from the teaching feeds into our research. So obviously that means that we have, if you like, an organic model of growth. So the teaching, as I say, is both at undergraduate and postgraduate level, and our research is world-class with multiple specialisms associated with it. So our degree programs at undergraduate level, we have a business computing degree, 4 years honours, with an element of industrial experience in the third year, and a B.Sc in computer science as well. Again, 4-year honours degree with industrial experience embedded in the degree. And we also have a B.Sc in data science, which we've had for 4 years. And then at the master's level, which I will obviously spend most of the time talking about, we have an M.Sc in computing with specialisms, or majors, if you like, the alternative way of speaking about them. And those specialisms are in artificial intelligence, in data analytics, and in secure software engineering. As well as that, but only at a part-time level, we have blockchain and distributed ledger technology and financial technology and innovation, which is a new program that we're beginning this year. The M.Sc in computing is based around the idea of offering majors that will allow graduates to emerge with the cutting edge skills that they need in order to develop and to assess high quality software and systems. And the idea really is that they're what I call fundamental courses. So we don't teach tools, we teach what the tools are based on. So when you learn about machine learning, you will learn the theory of machine learning, but you will also put the machine learning theory into practice. Okay, and within that, we have full-time and part-time majors in data analytics, artificial intelligence, and secure software engineering. And part-time only in blockchain and distributed ledger technology and financial technology and innovation. So what do they look like? Well, all of our taught masters, when they're full-time, are what we call a calendar year and not an academic year. So that means is you come in September in 1 year and you leave in September the next year. The reason that that happens is we have 2 semesters of taught modules, okay? Within each of those semesters, you will have 4 modules. So this year, your semester will begin in September and it will end, including the exams, before the end of the year, okay? And then the next semester will begin in January and it will end in and around the end of April. But that's not the end in total, because additionally to that, you have to develop a research project. We call it the practicum. We've taken the word from MIT, but we've manipulated it a little bit. And our view of a practicum is that each student should develop a research paper, which is publishable, okay? What we mean by that is it's not a thesis. We're not interested in people writing 150 pages, 80 of which is really background and 20 is their core work. So we just want the core work. So the core work is copied in what we call, or developed in what we call a practicum. And that is, as it says there, done after the 2 semesters are over and completed over the summer, okay? So let's look at the rest. So in artificial intelligence, okay, we have in the first semester a module on the foundations of AI, a module on, so that speaks for itself really, excuse me, a module on professional and research practice. So that will involve law, ethics, and reading and writing research papers and developing research papers. That's very important because it's going to feed into all your other work. We also feel it's important to have the fundamentals of statistical data analysis, because so many AI methods depend on a knowledge of statistics in order to understand their significance. We also have a module in data management and visualization, again, because of the importance of being able to explain your results in a manner that is both believable, but also that is true to the original results that you've created. So that's the first semester. And as I say, all of those modules take place before the winter break. And then the exams take place before the winter break as well. In the second semester then, move on to data analytics and data mining, which again is so important in terms of allowing AI techniques to analyze data. And then also machine learning, which again is increasingly important across a range of areas within computing and within those areas affected by computing. And then you have a choice. The choices change year by year, but examples would be statistical machine translation, which again is a very new and important way of handling non-local natural language. Okay, NLP as it used to be called. So then there's also an interesting module on the mechanics of search. In other words, the fundamentals of search approaches, again, using AI. And then there's one more core module, which is AI information and information seeking. Looks right across all the approaches that are associated with AI in handling information. So again, that finishes up, and around now, this time of the year, the exams would happen, okay? And then after that, but obviously you've been working on it all the time, you will produce your practicum paper, you will defend it, and in August, and then that practicum paper, if you like, hopefully will be published. So that in total gives you the 90 credits that are associated with our taught M.Sc within one calendar year. And that structure is the same for all. I'll show you the structure of part-time M.Sc later on. The big difference is it goes over 2 years. So when we look at data analytics, we have some similar modules and some that are different. So in the first semester, again, it's so important we have our research and professional practice for everybody, but there's also the data analytics of cloud technologies. Obviously, most serious data analytics involves cloud technologies, okay? Again, you need data management and you need statistical data analysis in a very big way. That statistical data analysis helps then for the machine learning and the data analytics in the second semester. But within data analytics, we also think it's very important to look at the more complex methods of modeling. So we look at mathematical modeling and computational science. So that looks into much more complicated methods of looking at real-time data and also looking at exponential data that changes over time. And then again, we have our AI information and information seeking. And then we have, again, the practicum, and that practicum is in the data analytics area. And again, that's has to be completed over the summer session. Okay. And then as our other full-time and part-time major specialism, we have secure software engineering. This is interesting because it's one of those areas which is less popular and yet much more needed at the moment. So I think if you've read anything about what's happened over the last while, the problems with security, the problems with ransomware, the problems with issues in general have gone through the roof really in terms of need. And yet it's less popular in the media, except when things go wrong. So this is the kind of classic situation where nobody needs secure software engineering until they really need it and it's too late. So we've had this on our books for a long time. It used to be called security and forensic computing. We've dropped the forensic because that's more of a consulted approach now, not done as much in-house. We've kept all the secure software engineering modules. So this is an in-depth look at the problems, the issues, the solutions, and the methods associated with developing secure code. So again, in the first semester, we have our research and professional practice as core, but then we look at system software, so operating systems, if you like, but in detail and from a security point of view. And then we look at the concept of introducing security into programming from the start. Okay, this is the approach that was developed by both IBM and Microsoft. The old adage that you can't make something secure after you've developed it. You have to make it secure while you're developing it. Okay, that's one very good module. And then obviously we need to know about cryptography. So we have cryptography and number theory in order for you to understand the fundamentals of cryptography. And obviously in order to be able to implement your own versions, but also to understand both the strength and the weakness of those that are around. That's the first semester. And then in the second semester, we look at alternative approaches to developing secure software. One is the concept of formal programming. So as you know, that idea of mathematically developing specifications in order to develop code, again, increasingly important. And then we look at the issues and the problems associated with concurrent programming. Again, something that is very important to look at from a security point of view. Then obviously we need to do testing as well. So we have a software process quality module that looks at all the new approaches to coverage, mutation testing, etc., that are out there now. And then looking at the developments beyond individual applications, we look at network security and application security. So that's the set of modules. And then obviously you need to develop a secure software engineering practicum as well. Okay, so they're all our full-time and part-time available programs. But from a part-time only point of view, we also have some programs. These aren't always available to non-EU students, but we have a new M.Sc in computing in financial technology and innovation, or if you like, FinTech. We've added innovation because we think that's incredibly important. And then we have an M.Sc in computing in blockchain and distributed ledger technologies. This is funded by a government program in Ireland called SKILLNET. So in other words, you apply through SKILLNET and it reduces the fees, etc. It's only part-time because you're meant to be in employment or you're meant to be seeking employment in order to be associated with it. Then we also have a graduate certificate in AI, which is funded by the Springboard Plus initiative, again, a government of Ireland initiative, and that's available again in part-time mode. The graduate certificate is, if you like, I won't call it an introduction because it's not, but a way of establishing some modules associated with a postgraduate AI degree that will be helpful immediately in your work or your seeking work but also can be built upon in order to get a full M.Sc later on. And then last year, because of the pandemic, there were individual modules made available under what was called an Irish Government Stimulus Programme. We don't know if that's going to be available this year, but we expect it will. Those kind of pieces of information will be available through the standard gov.ie, skillnet.ie, springboard.ie type places within Ireland. So what would a financial technology and innovation M.Sc look like? So again, as you couldn't expect, it's one full calendar year. We have CEA 640 in there again. But we also have a module from the business school here in DCU called Financial Innovation, okay, which looks at all of those approaches from a business point of view. And the other thing is to look at this is we have our years. So we have year one, semester one, only 2 modules before Christmas because they're doing it part-time. And then year one, semester 2, we have 2 more modules. We've one in data governance, which is incredibly important, especially from the point of view of data protection and privacy, but also in general for companies in order to understand and to control how their data is stored, where it's stored, how securely it's stored, etc. So that's a module that fits in very well here. And then we have a kind of classic innovation in financial technology, which is blockchain. So we have an introduction to blockchain and its applications, right? So that completes year one because it's part-time. So there's 4 modules completed. In the second year then, we have our statistical data analysis, again, incredibly important in order to evaluate financial technology approaches. And we also have a module in high-tech innovation and entrepreneurship. This is important because they're increasingly, because of its novelty, financial technology companies end up being startups. And there have been some incredibly successful startups in Ireland, which have been sold on obviously to very large companies then who want to use the technology that has been developed. So it's very important for students to understand that concept of entrepreneurship. And then our 2 familiar modules, if you like, machine learning and data analytics and data mining, because again, they're used a lot in the financial world. And finally, we have our practicum. It's slightly different in the sense we've broken it into 2 parts. Why? Well, because in financial technology, because it's new and because the types of research that you're going to do are quite novel, we've developed it that you have a design phase and then you have a delivery phase and the credits are broken. This is only in this particular case. Okay, so that's the structure. It's part-time, so therefore it's only available to EU students, if you like, and it's over 2 years. Then we have our blockchain and distributed ledger technologies, which is done in association with SKILLNET, an upskilling initiative by the Irish government. So again, over 2 years, so we have year one and year two. So year one now, the whole column there goes through semester one and semester two. So we have our CA 640 as you'd expect, but now we have cryptography because cryptography obviously is the basis of blockchain. Then in the second semester, we have our blockchain basics, and then we have cloud systems. And because quite obviously, most distributed ledger technology is based on some cloud-based approach. So that's all of first year. And then in the second year, we have an interesting program module from our colleagues in electronic engineering called blockchain scalability, which looks at how to improve and access and develop larger blockchains. Then we also have public key cryptography, very important, in order to look at, again, approaches that are going to make what we have, cryptography in the first semester, more useful from a blockchain point of view. And then in the second semester of year two, we have development of blockchain systems and a computer security module as well. So again, all based around the idea of blockchain. So obviously the practicum is going to be based on blockchain as well. And we've been running this program successfully now for a couple of years. So they're all the taught programs. So what else is happening here? Well, a lot really. We have our postgraduate research programs. The core of those is PhD by research. And it's a very stimulating environment here. I'm actually sitting in the postgraduate research lab. And if I move my screen slightly, you can see all the theses which have been developed by PhD and M.Sc students. They're not all of them, but they're a random sample, if you like. So it's a very stimulating environment. Research is done in areas, obviously, such as artificial intelligence, software engineering, data analytics, NLP, machine translation, scientific computing, and computer science. Currently, there are over 50 postgraduate research students, and there's a wide range of funded projects. All our projects are funded here. All our PhDs are funded at both national and international level. And because of that, the school enjoys really close links with industry. There are research collaborations with companies such as IBM, Google, Microsoft, Intel. And as you know, Dublin is a hub for all the EMEA locations, for Facebook, for Google itself, and for all the other, basically more large corporations than you can think of. So there, a lot of them are involved in collaborations. And that research background allows us then to feed into our teaching as well as the data analytics and language technology. There's also a lot of modeling in scientific computing. There's also sensor web technologies, and there's also cloud computing research being done. One reason why this is so popular and so prevalent is we have three really big research centers, really. Two located directly in our building. Beyond me, we have Insight, which is the Centre for Data Analytics, which is an EU-funded and SFI-funded research centre, which concentrates on data analytics projects and has done for a number of years, with recent success in attracting even more funds. That is across Ireland, so there will be Insight centres in various universities, and DCUs is one of the largest, and currently we have the head of Insight across Ireland located here in our building. So as well as that, on the far side, we have ADAPT. So ADAPT began its life in terms of machine translation, but now they talk about being content, technology, and generation specialists. So they do it multilingually across the world. And again, they're a huge source of funding from the SFI and from the EU and of graduate and postgraduate students. And we also have extensive links with LERO, which is the Irish Software Research Centre. And then within the school as well, we have an ArcSim centre, which looks at high-end computing and mathematical modeling. And then as well as that, there are projects in general software engineering and computer science, and projects across data analytics areas such as data science, etc. Okay, so because we have these research centers and research connections, our lecturers on the M.Sc work in the Insight centers. We have lecturers from Insight giving seminars and the whole thing, and ADAPT and LERO. So the whole thing is quite organic, and if you like, there's a great feedback. So for example, a lot of the practicums will be based on topics that have come from Insight or come from ADAPT or come from LERO. Okay, so that was a brief run through of the whole set. Obviously concentrating on postgraduate information that's associated with the School of Computing here in Dublin City University.